Hello students, our today's topic is principle of moment. Principle of moments. Okay. Okay, let's understood about this concept of principle of movement. Let we have a rod A B of length R. Okay, and there is a point in between A B. Let's say F. Okay. Now, if a force is applied at A downward, let's say the force is F1, this is the point O. Okay, so if the force at B is F2 and these two forces are act along the same line and at a perpendicular distance to one another, therefore if there is no rotational motion, that is the body or the rod AB is in rotational equilibrium. Okay, therefore we say that the rod is in equilibrium and the force F1 which able to produce the clockwise anti-clockwise rotation and force 2 which produce clockwise rotation is equal to each other. That means the body or rod AB is in rotational equilibrium. Therefore, we can state that according to this principle, if a body will be in rotational equilibrium if the algebraic sum of anti-clockwise motion due to load at A is equal to the clockwise motion due to effort at B. Therefore the net force at O is equal to 0. So the body AB is called in rotational equilibrium. Okay, now let force at a F1 equal to load and force at B F2 equal to effort okay, and the distance OA is called load arm and OB is called effort arm. Therefore, moment about O due to F1 and F2 is anti-clockwise moment is equal to F1 into load arm. Okay, that is F1 into, let's say this is R1, OA, that is F1 into R1 and clockwise moment is F2 into effort arm, that is F2 into OB, which is equal to F2 into R2. Therefore, according to principle of moment, about O, anti-clockwise moment equal to clockwise moment. Okay, that is F1 into R1 equal to F2 into R2. From here we calculate that F1 upon F2 equal to R2 upon R1, that is force is inversely proportional to R, which means the larger force is near to the center of mass point. Okay, this is the principle of moment. Okay, simple. It is as same as we calculate the moment of center of mass. Okay, this. Okay, next we have concept of moment of force. Or we say couple of forces. Okay, couple of moments. Okay. For this, when suppose we have a rod, as we discussed in the principle of moment, let's say this is point A, this is B, and this is O. Here A is called load, B is called effort. Okay, and let's say load is force F1 and this is force F2. This point O is called fulcrum. Okay, therefore if the moment about O is not equal, okay, that is F1 is greater than F2 or F2 is greater than F1 for these two cases. Okay, if F1 is greater than F2, so the body rotates about anti-clockwise. Okay, and if F2 is greater than F1, then body rotates about clockwise rotation, okay, or clockwise motion. So in this case, F1 and F2, two forces acting along a same distance A to B, and the forces are perpendicular to each other about the separation distance between the two. Then if the two forces F1 equal to F2, okay, then we observe that the body not able to move linearly along a straight line, but it gives an idea about turning. That is, if the forces applied at point A or B is little bit larger than the first, then the body is rotated around this point O. Okay, so this gives an idea of turning about the distance from O. Okay, so we can explain it. The moment of force, or torque due to force, okay, gives us the turning effect, okay, turning effect of the force about the fixed point okay, it is measured by the product of force and the perpendicular distance distance of the line of action of force from the axis of rotation. Okay, it is denoted by Greek letter tau. Okay, that is calculation of torque is torque tau is equal to magnitude of force into perpendicular distance of rotation. Okay, which is equal to torque F cross distance, let's say R. Okay, is vector R. Torque is a vector quantity. Okay, therefore this torque is equal to Fr sin theta eta cap, where eta cap is the direction of rotation. Okay, or it gives the direction of torque. For maximum torque, theta should be 90 degree, that is sin theta will become 1. So this torque is maximum, which is equal to F into R. From here we calculate the value of force. F is equal to torque upon radius of rotation. Okay, radius of rotation. Okay, now for parallel and anti-parallel case, that is force and radius of rotation parallel to each other. So theta is equal to 0 degree, in this case 180 degree, and for this is parallel case and this is anti-parallel case. Okay, for this theta is equal to 0 degree, so sin 180 degree is equal to 0 and sin 0 degree is 0. Therefore torque is minimum, which is equal to 0. Okay, this is the principle of torque. Now we will understood about the rectangular component of force. Rf sin phi. Okay, where phi is direction of torque. Okay, thank you.